In the previous video, we took a look at the idea or the concept of how we could inject a default route into OSPF on one of the routers. In this lab and video, we're going to go ahead and implement the configuration and verify that it works. So here's our game plan. Let's imagine that this is our service provider off this network here. And they've got an IP address at 10.1.0.99. And this is our interface gig 00 on R1 that is also connected to this network, and R1 is at the IP address of .1 on that network. So let's do two things. Number one, let's add a default route on R1 that points to 10.1.0.99 as the next hop. So he has a default route, and then we'll train R1 to share that default route with the rest of the OSPF network. So our syntax on R1 will look something like this. So on R1, we'll go into configuration mode, and we'll do an IP space route space, and then the IPv4 default route, which is 4 zeros in dotted decimal, followed by 4 more zeros in dotted decimal. And then we can specify, if we want to, the interface and, because it's on Ethernet, the next hop address. So for this example, let's go ahead and use gig 0/0 as the exit interface. Put a space there, and after that, we can then specify the next hop of 10.1.0.99. I want to reinforce here that if we don't add the interface, the Cisco router knows which interface, if you only have one, which interface to use to get there. And in a previous video, we took a look together at the pros and cons of when you might or might not use the egress or exit interface as part of a static route command. So here on R1, with that static default route in place, the next step would be to share that information about the default route with the rest of the OSPF network. And the way we're going to do that is we're going to go into router configuration mode. So we'll type in router space OSPF space, our process ID. We've been using 1, so we'll continue to use that. And then once in router configuration mode, we're going to use the command default-information space originate. And if we add the keyword always, that means that that default route will still be advertised even if for some reason router 1 loses its own default route. So with this plan in place, let's go up to the virtual lab and we'll implement and verify default routes inside of OSPF. So here on our management computer, which is DCNUG in the lab environment, we'll open up PuTTY in the upper left-hand corner. And then we'll click on the servers tab. We'll open up connections to R1 and repeat that process for R2 and for R3 and for R4. Perfect. All right, there's R1, R2, R3, and R4. And let's start on R1. And one of the great habits that we're building as we practice is we're going to verify what's in place before we start configuring. So a great way to do that is show IP OSPF. Is OSPF even running on this router? So show IP OSPF says indeed it is. And we can hit the space bar to continue. If we do a show IP protocols, that will show us information about dynamic routing protocols that are running, including OSPF. So show IP protocols says, yep, OSPF process ID is running. There's the router ID. And here's our network statement. That's the equivalent of our network statement that's causing router 1's interfaces to be included as part of OSPF. And as we continue a couple of our favorite OSPF commands, we could use show IP OSPF interface. And let's go ahead and use brief to get the Reader's Digest version. So we have 4 interfaces participating in OSPF. There's their respective costs, and there's their state. And one more just for grins, show IP OSPF neighbor, just to verify we have our neighborships. Great. And let's do one more command, show IP route. Press enter. And I'm going to hit Q to cancel that. And right here it says the gateway of last resort is not set. So if this router had a default route, it would show up here. It would also show up in the routing table as well. So let's go ahead and fix that. We'll do a config T and IP route, and we'll put in the Obi-Wan Kenobi route, just like that. And let's include the exit interface of gig, and it is 0/0 just for fun. In fact, let me show you what it looks like with and without it from a routing table perspective. That's good to see. So we'll put in the next hop of 10.1.0.99, press enter, and we'll do show IP route. So check this out. Here's that static route that we just added. So in the routing table, see how it doesn't include the exit interface? The router is going to figure that out very easily, what the exit interface is. Also notice that we have our default route as a gateway of last resort that also shows up here. Let's go back and take out that route. So I'm going to do a couple up arrows, a control A, and I'm going to put a no in front of that exact command. So that route is now gone. And a few up arrows again. Let's go ahead and add on the exit interface as well. So I'll put gig 0/0, press enter, and now if we do a couple up arrows and do a show IP route, check this out. See in the routing table, that static route now specifically includes that egress interface. So if we're doing static routes on serial interfaces, we can get away with just putting in the egress interface and that's it. But on Ethernet, it's a really great idea to always include the next hop IP address, whether or not you include the exit interface as part of that static route. All right, so now this router knows about a default route. R1 does. But if we went over to R2, and let's do that. Let's go to R2. And here on R2, if we do a show IP route, so R2 does not have a default route. So if R2 gets a packet and it does not have a route that matches the destination IP address in that IP packet, without a gateway of last resort, the router is going to drop that traffic. It can't forward it if it doesn't know how to forward it. So to solve that, we're going to go back to R1, and we're going to go to router configuration mode for OSPF, process ID 1, and we're going to use the command default -information originate, and if we want to, we can add the always keyword, which basically says I'm going to always advertise into OSPF a default route, whether or not I have one. So R1 has one at the moment. If we add the keyword always, it won't harm anything. So I'm going to plug it in there and press enter, and then we'll type in end. So now the fun part is this. Now that R1 is originating a default route into OSPF, we should be able to go to R2 or R3 or R4 and see a default route now show up on those devices that they've learned via OSPF. Let's take a look. So on the topology, R1 just injected the default route with this command into OSPF. And if we go back and look at R2 now, it should also know about a default route that it learned via OSPF. The same thing with R3 and R4. So we'll make a road trip back to R2. And here on R2, we'll do a show IP route one more time. I'll hit Q to cancel the output. And when I do Q, basically any other key besides enter for one line at a time or spacebar for one page at a time, that'll do it. On some firewalls, Q is the command to stop the scrolling. So that's why I often say Q. But any other key other than enter and space will do it as well. So with the output stopped, check this out. We now have this O, which represents an OSPF learned route. And that is a route to 0000/0, and the next hop is 10.12.0.1, which is R1's IP address on that network segment between R2 and R1. Also, it's representing here that a gateway of last resort is 10.12.0.1. Let's also go check out R3 and R4 because they should all have default routes now. So we do show IP route, press enter. From R3's perspective, it has a default route, and the next hop is R1 based on that last octet. 10.13.0.1. So next, let's take a look at R4, and we'll take a look at what he believes is the path he would use for his default route. So here in R4, we'll do a show IP route. And here we have this OSPF learned route, the default route with the next hop of 10.24.0.2, which is R2. So what have we done in this video and lab? We did three basic things. Number one, we added a default route to R1, one of our OSPF routers in our environment. Two, we told R1 with the default information originate always command to go ahead and inject that default route into OSPF. And the third thing we did is we went to the other routers and verified that they had dynamically learned a default route via OSPF. So I am glad that you joined me for this video and lab. I hope this has been informative for you, and I'd like to thank you for viewing.